we have to now go about the reason behind why is MRTS diminishing. So to know this, you must know the law of diminishing marginal product. Which says the following: if I keep capital constant and keep on increasing labor, then the marginal product of labor will keep on falling. Similarly, if I keep labor constant and keep on increasing capital, then again the marginal product of capital will keep on decreasing. Okay, now let's talk about an isoquant. Now let's talk about a point A and go to a point B. When I go from A to B, 1, the slope becomes steeper, from steeper to flatter. So just see, this is steeper and this is flatter. What does this say? It says that the rate at which you substitute falls, or MRTS falls. Now see another reason. When you go from A to B, if I take labor here and I take capital here, from A to B, labor increases, so marginal product of labor decreases. From A to B, capital decreases, so marginal product of capital increases. Now MRTS is MPL by MPK. MPL is decreasing, MPK is increasing, so this entire ratio is decreasing, so MRTS is decreasing. Okay, so this is the reason why MRTS falls. Now I want to talk about the different types of isoquants. So the first type of isoquant is the Cobb-Douglas isoquant that we have already seen, or the well-defined function, which is this. Right? And the function is of the form k to the power alpha l to the power beta. Let's find its MRTS. So MRTS will be MPL by MPK, which in this case will be how does output changes when labor changes, how does output changes when capital changes. So differentiate the function with respect to L, you will get differentiate it with respect to K, you will get when you solve you will get so this is MRTS. Okay, now coming to the next type of function, I want to talk about the min function. So my function, so because I will equate whatever comes inside the min, so I'll say L is equal to K, and since L by K is 1 by 1, I know that the king should pass through the 45-degree line. So this is the 45-degree line, and all my indifference curves will be like this. All my isocones will be like this. So these are my isocones. Okay. And now the third type is, so if I have to find the MRTS, can I do that? Yes, I can do it at different points. So for example, I take this region. For this region, MRTS is dk by dl, but L is not changing, so it is dk by 0, which is infinite. At kink, it's dk by dl, but both are not changing, so it's not defined. 0 by 0. Here it is again dk by dl, but k is not changing, so it's 0. Okay. So the third case that we want to come upon is the substitute goods. So suppose it is alpha L plus beta k. So how does my function looks like? So if I put L here and k here, so if k is 0, this is q by alpha, and if L is 0, this is q by beta, and this is my indifference curve. Isocont. So as I keep on increasing the value of q for higher and higher output, isocont would be, so the intercepts would be higher, and hence the isocont would be higher. Okay. So case 4. In that case, if I have to find the MRTS, it should be with respect to L upon with respect to k, so alpha by beta. So if I take max function, my isocones would be like this. Again, these kinks would be passing through the 45-degree line. Alright. This is all done in the consumer theory. We are just changing names kind of thing. The concepts remain the same. So let's go to the next function and the last function. So supposedly my function is root L plus k. So I know that its value should remain constant at some level, because this is in non-linear form, and its value should change. Okay. So how does my function look like? So labor is fixed at some level. Suppose at 10 it's fixed, so it's like this. This is the shape of my isocones. Okay, now the last thing that I want to talk about in this chapter is something which is known as the elasticity of substitution. Now, what is elasticity of substitution? So understand this as follows. Suppose I draw a general isocont. Now when I move from one point to another, there are two things that are happening simultaneously. What are the two things? So one is when I go from A to B, the ratio of labor to capital changes. So here labor upon capital, and here labor upon capital are different. Okay, because I am taking capital on the perpendicular axis, how would I write it? I will write the ratio of capital to labor, or capital labor ratio changes. So when I go from A to B, 1, capital labor ratio changes. Also, when I go from A to B, the slope changes. So it becomes from steeper to flatter. So 2 MR